web stream. And so for lecture stream, we have 100 students, and for web stream, we have 60 students. The labs will start from next week. I think you should know which lab you belong to. Okay, so please try to attend the lab. And the consultation is from 3 to 4 p.m. at my office. And if you got any questions, you can come to my office to discuss with me. But normally, I think the questions will only come up. You only get some questions when before the exam or before the submission deadline for the projects. My place is in K17 and room 201D. So you go up to level 2 and turn left. That's where my office is. The teaching assistant is called Xuefeng Chen. He is my PhD student. So if you get any questions, you can also send email to him. He also try to help you. And if he cannot help you, he will contact me, and I will try to solve the problem. We have 4 tutors. So besides Xuefeng, we also have Wei Li, Yu Peng, and Yu Hao. They are all PhD students in the database group. So they are all very experienced about this course. For discussion and QA, so I have tried Google Groups, I also tried Piazza, and also tried WebSam 3. But after these tries, I found out WebSam 3 is the most efficient way for you guys to submit questions, and also for me to answer questions. So once you post a question in the forum, I will receive email. So if I saw the email, I'll try to reply you as soon as possible. And okay, so that's about the course. So next, I'll do a little bit self-introduction about myself. My name is Xin Cao. Okay, so from the name, you know I'm Chinese, and actually you can also observe that from my English accent, you can know that I'm Chinese. So as usual, the majority of the class is still Chinese students. So I can see more than 1/2 of the students are from China. So you guys must be very happy because it is more easier for you to understand me, right? But for the other students, I hope that you could be tolerant to my English because I'm not a native English speaker, and sometimes I may make some mistakes, so do not laugh at me. And sometimes I may speak a little bit fast, just like now. Okay, I know I need to try to lower the pace down, but sometimes I just forget about that. And if you feel that you cannot understand something, or you thought you get some problems of understanding me, you just raise up your hand and ask your question. So I will try to answer your questions and also try to slow down my pace. Okay, this is my office number. It's not suggested to call me using this number because sometimes I may not be in the office. So the best way to contact me is through emails. Okay, and it's through WebSam 3 because you post a question and can see that in my email box. About my research interest, okay, so this is just for some students who might be interested in doing research. Okay, and if you are you consider to do a PhD student, so you can consider to see if you are interested in my research area. So my main research interest focus on database, data mining, big data technologies, and that's why I teach this course, right? And this is my homepage. There's some, that's my homepage. List my research interest and my paper list. Okay. So so far, I'm not sure if you got some questions about the course and about me. Okay. About course aims, according to the name of the course called Big Data Management. So what I aim to do in this course is that to introduce the concepts behind big data and some core technologies used in managing large-scale data sets, and a range of technologies for developing solutions for large-scale data analytics problems. And specifically in this course, we will learn Hadoop and Spark. We will learn 2 platforms, the most 2 popular platforms for big data analytics. However, because of the time limit, we only have 12 weeks, right? For these 12 weeks, it's not able to go deep into these topics. So it's kind of like tutorial or introduction to these topics. So what I do is to introduce to you these topics. But if you really want to learn more about these topics, so it's better for yourself to do some search on the web. There are a lot of documents available and a lot of, actually also a lot of online courses. So you can try to learn some more advanced topics on your own. And if you meet some problems, you are still welcome to discuss with me about these advanced topics. Okay. This course is intended for the students who want to understand modern large-scale data analytics systems. It covers a wide range of topics and technologies and will prepare you to be able to build such systems as well as use them efficiently and effectively to address challenges in big data management. Since big data, this topic is a new topic. So it's different from the other courses such as operating systems or big database. These courses are well developed for years. Okay, but for this course, it's not able to cover every aspect of big data management. So I just select some topics that I thought that are very important in big data management to you, and I also try to search for some big data courses from the other universities and try to also get some materials from them and integrate them into this course. For the lectures, so we will have 12 lectures, and except the last one. The last one is mainly for revision and for exam questions, explanations. And so the other 11 lectures will be used to introduce to the topics on big data management, and also about the typical applications of big data management. And I'll try my best to run in a more interactive mode and provide more examples. So providing more examples is simple. So I can just add more examples in the lecture slides. That's okay. But how to do interactive teaching actually is it's a challenge for me, because according to my experience, most of the time when I ask a question, so what I get is just silence. There's no feedback, and you guys just watch me, and so I don't know who got the answer. So I hope that this situation could be improved this semester. When I ask questions, someone could. I know actually most of you can't get answer, but the only problem is that maybe you are too shy, or you don't want to answer my question. Yeah, I can understand that kind of feeling, because I'm also a student for more than several years. Yeah, and yeah, when I was a student, I also do not want to answer the teacher's question. Yeah, I know that kind of feeling, but I just hope that you could cooperate with me, okay? And if you do not cooperate, then do not write something like this course should be teaching in a more interactive way in your feedback, because for the first semester of this course, I got some feedbacks from students, and they told me that you should teach in more interactive way. I think, okay, yeah, but you should also give me some feedback, right? So it's not just my duty, it's the duty for both of us. For some lectures, I'll try to run in a more practical manner. So I'll show you some example codes. So this codes you will practice in the labs, but in the lecture, I think it will be better for me to show you guys how to do some coding, and it will be easy for you to finish the labs and also to finish the projects. And the lecture length may vary a little bit, so sometimes maybe we will run over 3 hours, but sometimes maybe finish a little bit earlier. So every week we have 3 hours. I know 3 hours is kind of a torture for you, and I know it's really hard to concentrate on this course for 3 hours. Actually, it's hard to concentrate on anything for 3 hours, I know. So we'll have 2 short breaks, about 5 to 10 minutes. Around 7 o'clock and 8 o'clock. Just hope that you could try your best to follow me, okay? So, and that would save your time, actually. If you could not follow me, it means that you need to watch the video again and try to understand what these topics are about, okay? So I will assume that you will attend every lecture, or you will watch every video recording every week. Okay. And for the resources, we have 4 textbooks, and the major one is actually these 2. This is for the first half of this course, Hadoop, the definitive guide, and the the Hadoop MapReduce is mainly based on this textbook. And this is a very thick book and also very expensive. But I think the library will have some some copies for this book. And another way is that you could find the electronic version online. I'm sure you can find it. Okay. And the second one is mining of massive data set. This is a textbook for the second part of this course. It introduces some big data applications. For example, recommender systems and streaming data processing, something like that. And this book is also used as a textbook of a big data course in Stanford. So, well, for this one, you could see there's a website. So you just click the website, you will download the PDF version of this book. So it's very easy. And this is another book. It's called Data Intensive Text Processing with MapReduce. Also, some topics about MapReduce are from this textbook. And it's also available online. You can download the PDF. And the last one called Learning Spark. I can only find a very early version of this book, or kind of a draft version of this book, not the formal version. So we can also find it online. Some chapters about Spark comes from this textbook. And we can also have a lot of other references or readings, actually, so such as the tutorials provided by Hadoop, by Spark. So you can go to these websites to see the tutorials. And they will give you a good start for how to learn these topics. And also a lot of other online tutorials are also very useful. And if you may get some difficulties, you could try to search. There are a lot of documents and instructions on learning Spark and Hadoop MapReduce. Well, as I said, these topics are relatively new topic. So it's different from the other courses. So there's no fixed syllabus. So every university has their own strategy to teach this course. So you can also try to search the online courses, not online courses, search the courses provided by the other universities. Some courses actually they provide the slides to public. So you can also download slides from the courses provided from the other universities, such as some universities in the US. And they will also be useful if you would like to learn more. Okay. About prerequisites, actually this is very important. What this course assumes is that you have already finished the course 9024, Data Structures and Algorithms. Because in this course, 3 coding projects are relevant to algorithm design. So you need to design efficient algorithms for a given problem using MapReduce or using Spark. Okay. So without taking this course, you may get some difficulties of finishing the projects. And also, database is a prerequisite of this course because, so for data management, actually database is a first course for you, right? About relational database. And what you learn is how to manipulate data in a relational database, how to model the data as using the ER diagram, right? And you can create schemas and put them as tables in the relational database and do some queries. So that's the first step for you to know how to manage data. And in this course, we will compare the traditional way and the big data way. Okay. For traditional relational database, well, the schemas are fixed, they're just tables, and you use SQL to query the data. And but for big data, we have a lot of more flexible ways to deal with the large-scale data, including the platforms. There are a lot of platforms for different applications or for different types of data. And also for query languages, different from the relational database, we do not have a standard query language to retrieve the data. So with taking the database system course, you will see the difference between the traditional ways of dealing with data and the nowadays ways of dealing with big data. Okay. The most important thing is that you have solid programming skills in Java. Okay, because this course is based on Java. Last year, I got one student who who is not very familiar with Java, but he is very familiar with Python. If you want to do the projects or do the labs in Python, that's fine, that's okay, because for MapReduce or for a Spark, so they all provide Python APIs for you to use. So you can use Python to do the labs and also to do the projects. But the problem is that this course assumes that you will use Java. So all the teaching materials will be based on Java. And it means that if you get some difficulties or you get some problems, you are not able to find the references from the course. You need to find some, you need to seek help from the other sources, not from this course. And also the tutors, I think they are not familiar with Python as well. They mainly use Java for this course. So if you have some problems, the tutors may also not be able to help you. I'm not for sure. I need to check with them to see if one of them is familiar with Python. So that's about the programming language. So Java is used for MapReduce, and for Spark, we will learn a new language called Scala. Because this course is not a Scala course, so I can only use maybe 1 hour, 2 hours to introduce Scala briefly to you. So for the Spark projects and labs, it means that you need to spend more time to learn a new language, actually, and then to work on the projects and labs. The next important thing is that you must be familiar with working on Unix-style operating systems. At least you know how to do that, okay? I still remember for the first semester of this course, maybe because that is the first semester, so at least this is not emphasized. So some students, actually, they are not familiar with Unix-style operating systems. They enrolled in this course. So they are not satisfied with the labs provided because I assume that you know this knowledge, right? So I assume that you have this background. So I just asked you to do something like you should copy some files, or so do some kind of file management in the Linux, okay? But he doesn't know how to do that. So he asked me why I do not give detailed instructions for him. And sometimes he may ask some questions just like, what does CP mean? What does MV mean? It's really hard for us to answer these simple questions. It takes the tutor's time because each tutor needs to deal with about 20 to 25 students. So my suggestion is that if you really want to enroll in this course, you must be familiar with this. Okay, that's very important. And if you are not familiar with it now, you need to think about to learn something, some comments in Linux. Okay, because I will provide a virtual machine image to you based on Linux, and in the labs, what you use is also Linux operating system. So you need to think about to learn something about this if you do not know it now. And also, you should have some basic knowledge, very basic knowledge about linear algebra, such as you know what is a bracket space, what is a matrix, how to do the multiplication, and you need to know some knowledge about probability and statistics, and also you should know some kind of graph theory. Well, if you have already taken this course, data structures and algorithms, I think for this part, for graph part, it should be fine, it should be okay. And for this, as a side, so this course covers a wide range of topics. So I'm not able to go deep into each topic. So it means that we will not apply very advanced knowledge, advanced mathematics to some problems, but you still need to know some basic knowledge. Okay, so that's very important for you to finish the projects and also to take the final exam. So what are not important? So if you do not have experiences in MapReduce or Spark, that's totally fine. Okay, do not worry about that because this course will teach you from scratch. I assume you have no knowledge on MapReduce on Spark, and also I assume that you do not know about parallel or distributed programming. And so you don't need to worry about that. You have no experience on MapReduce or Spark, so that's not a problem. Okay. Okay. I know that you can still drop this course by the 4th week, right? So you can. I can't remember exactly. Okay. Anyway, so you can have a taste of this course for the first few weeks, and also the first project will be released in week 3. And at that time, you can see if you are able to finish this course, you are able to do the project for you, okay? And if you feel that that's very difficult, you should consider to quit this course and do not enroll. So my suggestion is that if you haven't taken these courses, or if you cannot produce correct Java program on your own, or you have never worked on Unix style operating systems, and you should consider to wait for the next semester, and because this course is taught in both semesters every year. And another thing is that you must have very good time management skills. Okay, I know that everyone is very busy because you may take 3 or 4 courses every semester, and every course will have some projects or assignments for you. And especially by the end of the semester, you also need to be busy with the exams. So sometimes I may consider to extend the deadline for the project submission. So that happens because I know you need more time. But most of the time, you need to be on time for these deadlines, okay? And I also know that some of you actually do a part-time job or even full-time job. And so that means that it's not very easy for you to attend the lecture and labs. So I still hope that you could attend the lectures and the labs. That is very important for you to perform good in this course. Okay. Okay. So any questions? Hi. I'm sorry. Oh, yeah. I also feel. How to, there's a button on the wall there? I'm not sure. I said the time. It works? Ah, okay, that's great. Okay. I feel some wind. I set temperature to 20 degrees. I hope it helps. Okay. The learning outcomes include the follows. I hope that after this course, you'll be able to elaborate the important characteristics of the big data. So that's what we will learn in this course. Okay. And you're able to develop an appropriate storage structure for the big data repository. So it's different from traditional relational database. You use your diagram to model problem and to convert your diagram to the schemas. So that's different. And you're also able to utilize the MapReduce paradigm to do the problems, or to do the big data problems. And we also learn Spark, so you're able to know how to utilize Spark platform for some simple big data problems. And finally, we will learn some typical applications. So you would also know how to develop efficient solutions for some analytical problems in big data. Talking about assessment, I think this is the most important part for you, right? We have 4 projects. So previously we have 4 projects, 4 coding projects plus 1 assignment. But according to the feedbacks, so many of our students complain that there are too many projects. Okay, so I reduced 1, so we only have 4 projects. And the first one is very simple, very easy, and only 10 marks. So according to my experience, so everyone can get 10 marks, the full mark, or 8 or 9. So that's not a problem for most of you. And the second one is also run to MapReduce. It's 25 marks. This is relatively harder and more difficult. And the third one is Spark, also 25 marks. And still not very difficult. So the weight of this project is not that high. The last one is very important for you because it has 40 marks. So you need to use MapReduce and Spark in AWS, a real big data processing service provider. You know AWS? I'm not sure if you know that. It's provided by Amazon. So you need to buy the services. And so, Amazon provide $100 credits for everyone. So you can apply for that. I will tell you how to do that. And $100 should be enough. But you must remember to terminate something you created in that platform, okay? Because last year, I received at least 2 emails who told me that they need to pay for more than $200 from their credit cards because they forget to terminate the services they created. So you must remember to do that. And also, for this project, you need to finish the lab on time. Last year, the major problem comes from that they didn't finish the lab about AWS. So they didn't know how to do this project. And about 3 or 4 days before the deadline for this project, they began to think about how to move my projects from my local machine to AWS. But okay, so everything may work fine in your local machine. But you know, it's just a virtual machine or your own computer. It works fine on your computer. It does not mean that it also works well in a real environment, you know. So you may miss some problems, and you may not be able to figure out what causes the problems. The last project, you need to run your code maybe for 1 hour or at least 10 to 20 minutes. And you know, for such projects, for such tasks, it's very hard to debug because if you get some problems, you need to start this the testing again, right? So it will spend you a lot of time. And that's why I said it's very important to finish the lab before doing the projects. It will save your time and also improve your marks. And for this project, so it depends. What my current assumption is that 3 weeks would be enough for you. But if it depends on your progress, okay. Hopefully I don't extend this deadline because if I extend the deadline further, then it may overlap with the exams. So that's not good. The final exam is 100 marks. It's a written exam, just written exam. I'm not sure if you know you get some friends who have enrolled in this course before. And so at least in the last semester, someone told me that they have some friends who have enrolled in this course in previous semesters. And their friends told him that this course is very easy and the exam is also very easy. Yeah, and that's why they decide to enroll in my course. But they regret it after the exam because last semester I received more than 30 emails to complain that the exam is so difficult, it's so hard. Okay, so this year I will balance this. Okay, I will make this much better. Not that simple and also not that hard. But it still means that you need to get well prepared for the exam. Okay, do not get any assumptions of the exam. Okay, yeah. So that's not your job. Your job is to get well prepared, not to make assumptions. Okay, and the final mark is computed as this harmonic mean. It's the marks about your projects and also the marks about your exam. And this double pass, so you need to get at least 40 marks in the final exam. But anyway, if you can get 40 marks, and I can guarantee that you will pass the course. And I've never get a student who get 40 marks in the exam and also fail this course, because everyone could get very good marks in the projects. Okay, and okay. For the coding projects, I have introduced a little bit. So the first one is a warm-up programming project on MapReduce, and it should be very easy for you. The second one is a little bit harder. It's still based on MapReduce. Third one on Spark. The last one on AWS using MapReduce and Spark. And both the results and source code will be checked. Please try to check that your code can produce the correct result before submission. Okay, because sometimes I always get some emails who complain that why I get so low mark. I said because we are not able to run your program. Okay, it just terminated with exceptions, and we cannot see the results. How can I give you a high mark? But he said it works fine in my computer, but I don't know. I didn't see that, right? Then I asked him to check again, and these students would always find some problems in their codes. Either they submit the wrong file, or they make some stupid mistakes. And so I will provide the sample input output for you, and means that you can use the sample input output to check, at least to do a very basic check for your program. Okay, if your code cannot produce the correct results using the sample input output, it means that your code is not correct. So at least this can help you to improve the quality of your code. But it does not also mean that your code passes the sample input output. You will also pass the test cases in the marking. Okay, you need to think about some other cases when you do the projects. The most important thing is about the plagiarism. Okay, so last year, some very some students just copy the other students' source code and then submit the projects to the system. Okay, and one student just copied without any change. If you do diff the two source codes, and the result is just empty, so it's no difference between the two source codes. And another guy is a little bit smarter, and he changed the name of the variables. Okay, yeah, but it's still easy to detect. Okay, and someone do even a more smarter way. They change the name of the functions or change the structure of the code, but still the major part are copied from the other students. Okay, I hope that this year you could try to do everything on your own, because there's no group projects. Just individual projects. Okay, you need to work on yourself. For group projects, I don't want to do group projects because it's really hard to give the weight to different group members. You know, and someone in one group, someone will always contribute the most. Who call the big leg, you know, in Chinese. Okay, and for the others, they'll just follow the big leg, okay, and they just do nothing. And this is very unfair to the guy who worked very hard for this course. So that's why individual project is developed for this course, okay. And for each project, we will, at the site, besides results, we also check the source code. And we are building a system to detect the plagiarism. Hopefully, this semester, we will not meet such problems, okay? Because how to deal with such cases is also a difficult decision for me, because I don't want to report this to the school. Okay, I just try to emphasize again about what I have said to them. So for this course, I do not want to fail any student. Okay, I don't want to fail any of you. So what I want to do is to introduce topics to you and hope that you can really learn something from the course, and that your knowledge you have learned in this course could help you in your future career. Okay, because big data is a very hot topic, right? So I think some topics would be used in your future career and also maybe useful for job hunting. And so that's my objective. So when something like this happened, okay, so for the last semester, okay, I just gave them 0 marks. So that's it for this project. I still allow them to attend the exam and to do the other projects. And the good news is that actually they all passed this course. They did very well in the exam because they know that they must get a very high mark in order to pass this course. So that's good news. But so anyway, I hope that you keep this in mind to do everything on your own. And you can discuss. That's totally okay. So for example, give you a problem and maybe you can't figure out how to solve this problem. You can get some hints from the other students, get some clues. Okay, that's totally okay. Some of you are very good friends, and it's okay to discuss. But the problem is that do not copy the code directly. At least after you know how to solve the problem, you know the algorithm, you need to implement this algorithm in by coding. Okay, you could still learn something, but otherwise you will just learn nothing. Okay, and okay, that's it. About the computing environment, I think you should know about this, such as a scale system, about how to submit your projects and how to check your submissions, check your marks. So you can read the wiki here. For the projects, they will be marked on Linux servers. Okay, you need to be able to upload, to run, and to test a program under Linux. And that's why you need to be familiar with Unix-style operating systems. Otherwise, you are not able to do these tasks. Okay. Talking about the final exam, it's 100 points and 2 hours exam. So previously it is 3 hours. So another problem of the exam is that because the time for the exam has been reduced from 3 hours to 2 hours, and most students found that they do not have enough time to answer all the questions. And again, this year I'll try to make it better and to try to reduce more questions from the exam to make you have enough time for the final exam. And you need to get at least 40 marks. Okay, that's very important. Very important. And there's no supplementary exam. Okay. If you have taken the exam, you have sat the exam, and you did not, and if you do not perform very well, so do not ask me to provide a supplementary exam, okay? So that's not fair to the other students. Yeah. Fairness, very important. Okay, plagiarism, okay, I'll talk about this. Okay, so still about the projects. Your code may fail due to some mistakes. So you must check that your code can produce the correct result by using the sample input output. And try to submit your projects on time before the deadline, okay? And otherwise, you'll get some penalties. And for each project, I will give you a detailed specification. You need to follow the instructions to submit a project. The reason is that if you make your code very because we need to use the scripts to mark your projects. So that's why you need to follow specifications. Otherwise, the tutors will not have enough time to check your projects one by one. So, I don't want to accept some excuses such as I'm too busy recently, or it's harder than I expected, something like that. So. You should do everything with, how to say, you need to plan, make a good plan for everything, okay? This is about the tentative course schedule. If there's no problem, we will follow this course schedule. So today is about course information and introduction to the big data. And the next 3 weeks is about MapReduce. And then another course on graph data processing. Then two courses on Spark, including some introduction to Scala. Next is some big data applications, including data mining, finding similar items, recommender systems. So finally, I will also introduce NoSQL technique and some other high-level MapReduce tools, such as HBase. It's one of the it's a well-known NoSQL system. So the last week is about revision and exam preparation. So I guess for this course, for this lecture and the last lecture, I can see most of you, but in the middle, I'm not sure. For the labs, we will have 5 labs on MapReduce and 3 labs on Spark, and 1 lab on the high-level MapReduce tools such as HBase and Hive and Peak. Oh, okay, Peak has been removed from this course, just HBase and Hive. And we also have 1 lab on AWS. So this lab is very important for you to finish the last project, okay? So you, because this is about money is very important. If you, you make some mistake, you know you need to pay by your credit cards. It's, so that's why it's very important to finish this lab. And I'm thinking to have 1 lab on big data machine learning platform, such as Spark has a machine learning lab, and Hadoop has it's called Mahout, yeah. And even Google has TensorFlow, but TensorFlow has been covered by the deep learning course, right? So maybe TensorFlow will not be covered. So Mahout or Spark machine learning lab may be covered in 1 lab. But it still depends, because this is the last lab, and many of you will be busy with exams, so I'm not sure that lab will be useful to you. So this tentative. For the virtual machine, in the labs, you will see Ubuntu already installed for you. So in this virtual machine image, we have MapReduce already installed, but Spark is not installed. So that's for the lab environment. And I provided 2 images to you. One is a raw Ubuntu 14.04, and another one is operating system with pre-installed Hadoop and Eclipse plugin, and also Spark. So at the beginning, I think you could use this one, because how to configure the operating system to install Hadoop is also a little bit tricky. So it's not that useful, but just you need to know how to do that is very, very tricky. And you can use this image with pre-installed Hadoop and just focus on MapReduce programming. So that's it. Okay. So this step is because that I made a stupid mistake. So that's why you need to remove this name to this one. I'm sorry about that. Okay. You don't need to do this right now. Okay. You can after the first lab, next week after the first lab, you can download this virtual machine image. And also, if you are not able to come to the lab, you can also use this virtual machine image to do the labs. Okay. Hi. Yeah, sure, you can definitely do that. But at the site, how to configure your operating system and how to install Hadoop is a little bit tricky. For different operating systems, such as Mac and Linux, different release of Linux and for Windows, we have different configurations for these different operating systems. I'm not able to provide all the configuration instructions, so I will try to provide one based on this raw operating system. Okay, then you can do the Hadoop installation and configuration on this raw image. Okay, and after you practice everything in the virtual machine image, then you can think about if you can install to your own machine, to your Mac or to your Linux or even Windows. Okay. Okay, so it's a last thing. So by the end of the semester, you will receive email to ask you to provide some feedbacks for this course and also for my teaching. And your feedback are very important. So important for this course, for me to improve the quality of this course, and also important for my job. You know, if I get a very low mark, I may get some problems. I need to talk with the head of school to check what is the problem. And the Also because this is about new topic, so you know the big data technologies keep evolving. You can think about 2 years ago or 3 years ago, some knowledge actually they haven't been developed yet, but nowadays they are very popular. So the course materials need to be updated correspondingly. So I will see your feedback and think about it for the next semester for the future students what I need to update. Okay, and also can advise where I can improve after each lecture. So remember for the first semester of this course, I have students called Simon, who is an IT support guy in the computer science department. He's a very nice guy, and every lecture he will give me some suggestions to my English. He will tell me, oh, what you made mistakes. For this word, you cannot pronounce like that, or for this meaning, you cannot use that word. So that's very helpful. And if you could do that, I will appreciate a lot. So now we have changed from another feedback system to my experience. You use my experience system to provide feedback. Okay. I've said that I will assume you will attend every lecture and or watch the video recordings every week. So why it is important? So I just get this figure from, I can't remember from where, but I think it is very meaningful. So you can see the numbers here. So generally, how much you will remember? You will remember 10% of what you read, and 20% about what you hear, and 30% of what you see, and 50% about what you hear and see, and 70% of what you say and write, and 90% of what you do. You know, so attending lectures, at least I can guarantee that you will achieve 50% of what you hear and see. You will hear my teaching, and you see the slides and see the interactions between you guys and me. But if you just read the slides by yourself, there's only 10%. So you need to spend more time to learn the topics. Okay. Actually, the best way for you to practice is to ask you to prepare some presentation. For example, I give you one topic, and you need to introduce this topic to the others. I think that is the best way for you to learn. That because now we have so many students, it's not possible to do that. And what I can do is to use the lectures to make you understand the topics as much as possible, and also provide the practical examples, also the labs for you to practice. By coding, you can understand more, because during the coding, sometimes it seems that you understand the topics, especially for MapReduce. It seems that the concepts are very easy to understand, but when you try to apply this knowledge, apply these concepts into the real problem, you will see there are a lot of tricky parts, some more details. Actually, you need to deal with that. Okay. Next, I will begin to introduce big data. But before that, we can have a short break. And also, if you have questions, you can come to talk to me. Okay. We will have about 5 minutes short break. 对，它有一个叫做模式。对对对，这都会现在已经3.9了，但我们 Live 还是用的2.7.2的，最近的那个 stable 的 release。
我第3版是不是可以用？
应该没什么问题，因为现在没有涉及到那个 advanced part，所以应该是没有问题。
谢谢。
Is that possible to do the labs because
Yeah,
I'm used to learn by mind?
Yeah, I just said you can use virtual image provided to do the lab. Okay, but the problem is that, like I said, so you may get some problems, you know. But if you attach that, filters can help you. But if you do it on your own, it means you may spend more time on searching how to solve this problem. So that's only the thing.
And are the labs going to be marked?
No, not be marked. Okay. Right. So attendance is not compulsory, but just strongly recommended.
Yeah.
Okay.
No, it's because in the other class I used to come to labs only to take some doubts, you know, just to ask some questions and do it my home. Because I'm used to do everything and synchronize with people to keep my history of my project.
Okay. Yeah.
Thanks.
It's just up to you. Alright guys, let's continue to the next part. So I just finished the introduction to the course. So next we will begin the introduction to big data. It's so the real start of the course. Okay. And so what is big data? So actually big data is just a buzzword. It's really hard to define big data. And there's no standard definition. Well, I just copied some sentences from Wikipedia. You can also see these sentences from Wikipedia. So big data is a term for data sets that are so voluminous. How to pronounce? Because the previous version is so large that now they change the word or complex that traditional data processing application software are inadequate to deal with them. So you see, it means that the size is two-dimension. Okay, first data is too big, too large, or too complex, and so large just means the volume. There's a lot of data, and complex means the complexity of the data. So the traditional data processing application software, such as regional database systems, they are not easy, not adequate to deal with such data. You can see from the concept actually that it does not tell you what is big data. It just tell you that okay, for the traditional techniques, the data cannot be processed. So that's it. Well, the challenges include capture, storage, analysis, data curation, search, sharing, transfer, visualization, querying, updating, and information privacy. You can also see that it covers so wide range of topics. A lot of topics are relevant to big data. According to the concept, actually, this can be this could be understood, right? Because it just means that if the data is so large and complex, and your traditional techniques are not able to deal with, they can be called big data problems. So definitely, in almost all areas, you will meet this problem because nowadays the data is much more complex and the size is so large. Normally, this term big data refers simply to the use of predictive analytics, user behavior analytics, or certain other advanced data analytic methods that extract value from data and sell them to a particular size of data set. So you need to get some value from the data to do something. Okay, so that's normally the big data, what that big data means. Analysis of data sets can find new correlations to these some examples: spot business trends, prevent diseases, combat crime, and so on. So a lot of applications are relevant to big data. So I think nowadays, big data, this word could much be more clear compared to the early years. So there's very famous joke about big data. I'm not sure if you know that. I'll show it to you. So it's published by a professor in Duke University, and it's in Facebook. I think what he said is just exactly the situation of big data. Many researchers or many companies, they claim that they are doing big data, but actually, I don't think they are able to explain what they have done for big data. Just because this is a hot topic, so I need to do it, and then I claim that I do it. So that's it. For the course, so instead of talking about this buzzword, talking about big data, so what I will introduce is the following topics. So first, the first part of this course is about the a crowded application ecosystems, and including Hadoop, MapReduce, and Spark. So there's two platforms we will learn for big data analytics. And we will also touch the other platforms such as NoSQL systems, including HBase. MongoDB and Neo4j will not be covered. So it just means that MongoDB is the most popular NoSQL system used nowadays. Neo4j is another graph database, also a NoSQL system. And Prego, developed by Google. And in Hadoop, in Apache project, so we have a Giraffe project using the idea of Prego, because Prego is not open source, so we are not able to use Prego, but we can use Prego-like systems such as Giraffe, and also in Spark. There's a GraphX component. So Spark GraphX is used for graph data processing. It also adopts Prego-like graph operators. So that's the first part of this course. And the second part of this course is about data science and data management, some applications. So specifically, we will learn about finding similar items. And it's one of the most useful topic in many problems. So for example, in Google search, actually there's one application of finding similar items. So you search something and the similar results will be returned to you. And graph data processing, and also a very useful problem. And streaming data processing. So this about data is not static. So instead, data is dynamic. So you receive what you try to deal with is a stream of data, not a set of data. So that's the difference. And finally, some machine learning technologies. So specifically, I think I will focus on some techniques on recommender systems, but I'll see if we have time to introduce more machine learning topics, because machine learning is not focus of this course. We have some other machine learning courses, right? Also deep learning, and that is a very popular course. I think a lot of you may already enroll in that course. About the data source, so who is generating big data? So actually everyone is contributing to big data. So you, me, so everyone is doing that, especially in the social network area. So we have Facebook accounts, we have Twitter accounts. So in China we have WeChat, we have Weibo. So all these social media, actually we are generating the data in these platforms, and this contributes to the big data. And some other, such as government, the Homeland Security, or e-commerce, or financial services, including the traditional financial services, or nowadays the digital currencies, right? Also in the search engines, Google, Microsoft Bings, and a lot of Google Plus. So almost everyone is a contributor to big data. Talking about big data, since it's not easy to define big data, but we are able to describe big data. Okay, so that's a little bit different. At an early age, the researchers began to use three characteristics, three V's, to describe big data. That's as shown in this figure. It's volume, variety, and velocity. So talking about volume, it means that it's the most basic idea, basic impression of big data, right? So given you big data, so what to think about is that we have a huge amount of data. So that's about volume. It means that the size of data you need to deal with is increasing from gigabytes, terabytes to zettabytes. You know. And for variety, so in maybe 20 or even longer years ago, 20 years ago, in companies, the relational database would already be enough for you to manage the data used in the company, such as the ERP system, okay, the enterprise resource planning system. And what you need to do is just to record the transactions between the customers and the business. And the query is mainly based on these transactions and do some kind of statistics, okay? And the data size will not be very large. But nowadays, the data is more and more complex. So from structured data, the structured data, such as the data organized by tables, okay, you have a schema, and the schema defines the format of the data. It's a structured data. And to both structured and unstructured data, you need to deal with. That's about the variety of the data. And the last V is called velocity. So it means that the data is not dealt with as a batch, and instead you need to deal with the streaming data. So as a site, so the data is not just there and given to you, you deal with that. But instead, data is dynamic. The data is is kept being generated, such as you can think about in Twitter, right? So in Twitter, every day, in the Twitter system will receive a lot of tweets. And if you do some kind of search over these tweets, so you're not dealing with something already there. You need to deal with some data newly generated. So how to return some real-time results to the users, how to deal with such problems in a real-time manner is a very big challenge. Okay. So this is about the data size increase from early years to now. So at the beginning, the ERP, just some transaction details, and then CRM, and the web, if you have you can remember, you can still know the concept of web version 2. So web version 2 just means that, okay, as the users, us, we can participate in, we can contribute to the data of the web, rather than just browse the data provided by the content providers. And to now, the big data area is much, much more complicated. You can see the data can come from different applications, including the business data and GPS data, location data, and social interaction data, and some other kind of videos, images, and a lot of types of data are available now. And for one application, actually for many applications, you are not dealing with just one type of data, right? You are dealing with different types of data. So for example, in Facebook, you can post videos, images, and you can post texts. So if you do a search engine, you are not just search one type of the data, you are search different types of, you are search multimedia data. Okay. For the first V, it's called volume. It's about the scale of the data. I need to update the figure, but I didn't find the statistic in 2017. And in 2018, so the data generated is about 8 zettabytes for in the whole year. It is predicted that about 44 or 45 zettabytes will be generated in year 2020. And according to many reports from different companies, such as Oracle, Cisco, so they reported that the data volume increased almost exponentially. So that's the amount of data stored by the average company today. But I think maybe just 1 or 2 years later, we'll move from terabytes to petabytes, and exabytes to zettabytes. You need to deal with much, much more data. And this is another figure from Twitter. So the number of tweets per day, from 20. I'm sorry, it's not very easy to see. From 2007 to 2016, so you can see it's almost increased exponentially. Okay. This is another report about the Twitter. Some statistics from Twitter. And you can see that the total number of monthly active Twitter users is about 330 million. The last update is at the beginning of this year. And the total number of tweets sent per day is about 500 million. I think nowadays it should be much, much larger. And for number of Twitter daily active users is about 100 million. So you can think about, for a company like Twitter, it needs to deal with so large and so complex data. So how to do these data analytics and data management tasks is really a big challenge. Okay. For the next V is called rarity. It's about the complexity of the data. So traditional data is just, you can use relational model to describe it, and also use the tables to store the relational data. And what you need to record about the transactions, okay? And the query is also very easy because you already have something like SQL to search the data. And someone who does not have the coding abilities is also able to do some data analytic tasks using SQL. But nowadays, besides written data, we have much more types, such as text data. And for the webs, what we are mainly browsing is about the text. We read the news, and we read some other. We read the novels or some other types of text data, and also semi-structured data in XML format, and graph data, such as in social networks, and user relationships are modeled as a graph, and also the tweets, retweets, or comments. These behaviors can also be modeled as a graph, as a user graph. Semantic web. So semantic web is modeled as RDF. It's a kind of graph with 3 triples. So one node and another node has some relations. So this kind of semantic web structure. And streaming data, just like in Twitter, right? So every day, the users are generating a lot of tweets, and because the data sizes are very huge, and normally you are not able to store the data and then do something again and again based on the data. You are only able to scan the data once. So you have some system, and data flows to your system, and then you use some algorithms or use some data structures to record some information and use this information to provide some statistics to the user query. And one single application can involve many types of data. So that's why so nowadays applications is more challenging compared to early years, just using relational data. From another point of view, because data can also come from different sources. So for example, movie reviews can be from IMDb and Rotten Tomatoes, right? From different sources, actually the reviews may be, they cannot be the same. So how to provide this, how to do some kind of data analytics from heterogeneous data sources is also a challenging task. Also for product reviews from different provider websites is also, that can also be different. So in order to extract the knowledge, for sometimes you need to use all these types of data, and you need to find the links, the connections between them to extract the knowledge. And here's one example about a single view to the customer. So as a customer, so us, so think about what we have. Okay, so we have bank accounts, so the banking finance. We have different credit cards. We have accounts in different banks. And in different banks, we can have different behaviors, different transactions. On social media, we have different accounts, Pinterest, Twitter, Facebook, YouTube. A lot of, we are doing different things in different social media applications. And for gaming, entertainment, we watch videos, Netflix, and for purchase, we can buy something from Alibaba, eBay, Amazon. And so for one customer, we could have so many different types of data, right? So we generate these types of data. We can also upload videos, images, and so it's just about one single customer. Many types of data could be relevant to such a customer. Well, from a global view, so the data could be linked together, right? So for different applications, they could be linked. The email, YouTube, LinkedIn, Twitter, Google+, and these different applications, actually we can try to link them to a single user, okay, and to find some useful observations from the connections of the data, and so they can also be linked to another user, right? Another user also have many social links. So by linking all the data together, we can build a diversified social network. And then from such complex social network, there's a lot of values. Could be useful to the business or even to the government to do some policy decision, right? The last V is called velocity. It's about speed of the data. So data is being generated fast, and it means that it also needs to be processed fast, especially for online data analytics. So online and offline are different. So offline, just like the data is already there, so it's okay how long time it takes for you to deal with the data because it's offline. But for online data analytics, you must provide some results instantly in a real-time manner. And if you do some decisions late, means that you may miss some opportunities. Okay, so these are some examples, such as e-promotions. It can be based on your current location and based on your purchase history to predict what you will like. But if you are not able to do a real-time prediction, if you have already passed this location, so then if you send the promotion about this business to you, it's meaningless because you are already far away from that business, right? So the system must be able to deal with such online analytic problems. And for healthcare monitoring, it's more important. It's about life. And we can have some sensors to monitor your activities and the body to get some analysis, and then to predict if you behave normally or there's some problems, or if you need some treatment immediately, right? If you are not able to do this in a very short time period, then something may happen. Some bad things may happen. And also disaster management and response. For these applications, all requires that you must be able to deal with the data that is being generated fast, and you also need to provide the results in a real time. Okay. I still use Twitter as an example for the velocity. Okay. So this statistics in Twitter. So every second, okay, we have about 6,000 or 7,000 tweets are tweeted on Twitter, and then it corresponds to about 350,000 tweets per minute, and about 500 million tweets per day, and around 200 billion tweets per year. I found a very interesting website. So you can see what happened just in 1 second. So let's click this website. Okay, so you can see what happened in 1 second. This is about tweets. Oh, 8,000. Oh, much more than I expected. That's tweets. And next, so what's this? Oh, Instagram, about 831 photos uploaded in Instagram. This is about Tumblr, and this is Skype calls, and this is internet traffic. Or you can see in 1 second we will have 54,000 gigabytes of internet traffic. So you can see how much data we need to deal with nowadays, and how fast data is being generated. Okay. We also have this is a very interesting website. So now let's go back to the characteristics of big data again. So what you need to remember is that, so if someone asks you what is big data, well, you can say that, okay, it's hard to define big data, but I can describe it for you. So what is big data? So if the data has the following properties, so volume, which has a very large volume, is about the size of the data, and variety means the type of the data is very complex. It's about complexity of the data, and the last thing is velocity, about the speed, and the data is being generated very fast. So that's about the big data problems. If your application need to deal with such data, then your application is a big data application. Okay, so it's a very general concept, not very strict definition. So that's most important 3 V's for big data characteristics. And later, the researchers, also the people from industry, began to use more V's to describe big data. So we have, for example, we have 6 V's. What more V's we have? We can have veracity. So it's about data quality issues. So the data quality is also very important. And visibility or visualization. Actually, visibility and visualization is not the same. They are not the same, but they are relevant. Okay, so I just put them together. Visibility means that your data need to be able to be accessed, to be seen by the public or by the people. Otherwise, there's no meaning. It's not meaningful to use the data, right? If it is invisible, and visualization means that this kind of user interaction. It's just one way for the user to understand the data. We can visualize the management process or the management results of big data. So they will be easy for us to understand what happened and what kind of values can be detected from the data. I'll show an example later. And the last one, actually also the most important one, is about the value. And what we want to use big data, right, is we want to get the value from data. So the value is hidden inside the big data. And what we want to do is to analyze the data and get the value out and to earn some money. So that's the most important thing. Okay, so let's talk about something more about these more V's. So first one is about veracity. It's kind of to describe the quality and the trust of the data. So the data is you can use this equation to understand the data as a quantity plus quality. So the quantity is just about the size, the volume of the data, and the quality means how good data is. Okay, if you have very huge amount of data, but the quality is very, very low, then this data set is not useful because you are not able to get useful information or knowledge from the noisy data. Okay, so when you talk about big data, most of the time we mean the quantity, but the problem is that in real world, the data we can obtain is not of good quality. So according to my experience, so sometimes I need to do some research based on the data crawled from social media applications, such as from Twitter or from Foursquare, from Weibo. And from these applications, after we crawl the data, we always need to clean the data. Otherwise, there will be a lot of noises that are not relevant to my research. And if I just use the raw data, I will not be able to get good results, such as for prediction, for recommendation. You always need to clean the data first. And so that's about the veracity. One thing, the quality of the data is very important. And actually, for data cleaning is one research topic in the big data area, how to clean the data. A lot of researchers are working on this topic. And another thing is that if we can trust answers to our queries, okay, it's also about the data, but now we talk about the trust, because the dirty data can lead us to some kind of misunderstanding of the data, right? It can lead to misleading financial reports, or to some wrong decision making. Okay, that means that we will lose some revenue or credibility, and we may lose, for business, they may lose customers. Okay, so how to guarantee that the results you obtain from data is trustable is also a very important question. And the study of the data quality is as important as the data quantity. Okay, you cannot just think about how we can deal with the huge size of data. Think about how we can do it efficiently. You also need to think about how we can do it effectively. Okay, how we can get the results, get the analytic results of high quality. So that's also very important. So it's another example relevant to veracity. The data in real life is often dirty, and I get this from some websites. You can see that in UK, 81 million national insurance numbers, but only 60 million eligible citizens. Okay, and in US, about 98,000 deaths each year caused by errors in medical data, because they made some mistakes in the medical data, and this caused some severe problems. And in Australia, and every year, not every year, so it's just a rough statistic, about 500,000 dead people that still retain active Medicare cards. Okay. And so that's the fifth V, the fourth V, okay. And for visibility and visualization, so as a side, they are not the same thing, but still kind of relevant. And visibility is the state of being able to see or be seen. It implies. It means that the data should be visible or accessible by users. So without the visibility, the big data is just meaningless. Okay. And for visualization, I use this example. I think it's a very good figure. I don't know what kind of application did they use to draw this figure. So this is a bike ride across Chicago. So from here to here is just one trajectory provided by users. They have ride from this location to another location. So from the visualization of the results, you can see that. So in this example, the bike rides, okay, we can know which area are hot areas. So many people will ride to that location. So I think normally it could be the public parks, right, or some other things relevant to entertainment. So this visualization. In the big data area, we have a lot of tools to do visualization, but this is not covered in this course. So visualization is also a research topic. So how to, I think it's about HCI, about human-computer interaction. So how to make your application be easier to be understood by the users. That's also very important. The last important thing is about the value. So why is this very easy to understand? Value just means the big data means big value, right? But how to get the value is our objective. So if the data does not provide value towards some meaningful goal, then it's just meaningless. Okay. This is a very good figure for you to memorize the 6 V's. So I get this from a talk by some guys from IBM. So you can also use these figures to understand the 6 V's. So volume, it just means the size of the data at rest. Okay. So early years, we do not need to deal with very large data set, but nowadays the size of the data has been increased dramatically. And next is called velocity. And you can see the dots are moving. Okay. And it's called data in motion. So we are not dealing with static data. We are dealing with dynamic data, streaming data. And we also need to provide real-time analytics for many online applications. So the velocity is about the speed of the data, about the scale of the data in motion. And rarity is about the complexity of the data, called data in many forms. You can see we use different colors to represent the dots. So the data could be structured or unstructured and could be of different types, such as text, video, images, other kind of multimedia. And veracity. So this is, you can see it's not for sure. Some dots are much bigger than the others because we are not sure where it is. We know that this dot is just in this area, but not for sure where it is exactly. So data in doubt, can be data in doubt. So you can see from the figure that actually it means that the data is not of good quality. Okay, it's not like what we assume. So for each piece of data, we know what it is like, but sometimes there are some uncertainties. Okay, so how to deal with these uncertainties? How to guarantee that the results, the analytic results, are trustable? So that's about veracity tasks. The challenge in big data. And visibility, well, it's here in this figure, it's called data is open. That means that it could be accessed by the public. And for last one, it's value. So the data of many values. So how to get the values hidden in the big data is one of the most important tasks in the big data problems. Okay, so now you can try to memorize 6 characteristics of big data. So volume, about scale, velocity, about speed, variety, about complexity, veracity, about quality and trust, visibility, just visibility, accessibility, and next value. Okay, so at least I hope that after this course, maybe you are still not very clear about what is big data, but at least you know that big data has 6 characteristics about these 6 V's. Okay. So far, any questions? Okay. Actually, we have more V's. I searched today how many V's. At most, I found 42 V's for big data. I think the guys are trying to use all the words starting by V to describe big data. So some other V's, such as variability. I don't know what is I think it's only slightly different from the from this variety, but now it's called variability. And volatility, and you can see this from this link. There's a paper, not a paper, a white paper to describe how many V's for big data. In 2016, okay. Now 2 years passed. I guess there must be more Vs. How many Vs? They use 1, 2. Oh, they even give the years when the V is being used to describe big data. Oh, they use 90 Vs. Okay. So I didn't find a later version for this document. So I guess there must be more Vs, but I don't think they are quite useful. For you can just try to memorize the 6 Vs. That's most important for describing big data. Okay. If you search big data in Google or generate some tech cloud for the documents relevant to big data, you can see something like this. We call it big clouds. So that's to extract the most relevant keywords to big data. So that's from different sources. You can see analytics. So that's almost the most important word to big data, because what we want to do is to analyze the data to get the values. Okay, and the storage. So storage is about how to store data, because you have a huge amount of data, but how to store them is a big problem. So for a single computer, normally it is not easy to store all of them. So we need to think about how to store the big data in a distributed environment. And let me see some other things. Petabytes is still about the volume, the scale, and search. Okay, search is about how to get the relevant results from the huge amount of data. Analysis, yeah, okay. So that's about a brief introduction of big data. So you can see that actually we do not define big data, but instead we describe big data, use the different characteristics. And why we want to start big data technologies, and also why we want to open this course to guys, just because now that is one of the most hot topic in both research and industry. So for in research, big data plus AI can generate a lot of interesting applications. And in industry, many companies begin to, they are facing this problem actually, such as in Twitter, right? In Twitter, they need to deal with huge amount of data and being generated very fast. So it is actually highly demanded in real world. A lot of applications need to deal with the so-called big data. And also for you, you can have a promising future career to do different types of jobs relevant to big data, such as social marketing, healthcare, and some other kind of data analysis jobs to get value out from the big data. And also now for the most important thing is to get enough credits for you to graduate, right? So this figure shows big data open source tools. So one good thing for big data is that many tools are open source. Okay, so think about when you learn database. I think not only the most popular database is one is MySQL, and another one is the one you use the database is called Postgres. Yeah. So the two are open source, right? But for the others, they are all not open source. So it means that you need to buy the services. But for big data problems, you can just download these open source tools to develop your system and to design your solutions for for your problems. So for example, in machine learning, we have this is Spark ML Leap. We will briefly touch this. And also we have Mehawt here, and also some other tools provided by different companies. Or Vika is also open source. It provides many data mining or machine learning tools such as clustering, classification. You can just use the API provided to you to work on some problem. For search, we have Elasticsearch and Solr. It's Apache projects. And visualization, just one, but actually I show you some more tools. For the framework, what we will learn is Hadoop MapReduce. So Hadoop MapReduce is built upon HDFS. So the data is first stored in HDFS, then fetched by the MapReduce program. And Yawn is a resource manager, also used in this MapReduce framework. And Spark, we also learn about how to use Spark, another way to deal with big data. And also methods, I think we also have Microsoft Azure. Where is the Microsoft Azure? Oh, it's not in this figure. So anyway, there are a lot of platforms to deal with big data. For data access, it's kind of relevant to database, but they are different from database, such as Cassandra is from Facebook, and HBase is an Apache project, MongoDB, and for NoSQL, NoSQL applications. So we have different tools to deal with different types of data. And for query, we have Pig and Hive. So Hive provides HQL, Hive query language. The format is very similar to SQL. So the idea is that to let the people who are not able, who do not know how to program, do not know how to use MapReduce to program, still be able to use MapReduce to do data analytic jobs. So you can just write SQL-like statements to do something, such like search, or do some kind of statistics to get some statistics from the data. And coordination, and so this is for streaming data. Real time, it means that you need to deal with streaming data, not static data. Storm is developed by Twitter. So Twitter uses Storm to deal with their streaming tweets, and Spark, Spark streaming is one component provided by Spark. Okay. So you can see that because big data covers a wide range of applications, so which tool to use in your application actually is not easy to identify. So you first need to analyze your program or your problem, and you need to think about first what type of data you are trying to deal with, and next is to think about what kind of problems you need to solve, and then you make a decision which tool to use for your application, because different tools, they suit different applications. It's very different from the relational database. So in relational database, the major thing is that you know how to define schemas to model your data. But all the applications use the same thing, use a relational database, use SQL to do query. But here, you use different platforms, different tools. Okay. And for the course, what will be covered? First topic is about big data management tools. And we will learn MapReduce. And these topics will be briefly introduced, like Yawn, HDFS. Yawn is a resource manager. HDFS is called Hadoop distributed file system. So it's a distributed file system. And on top of DFS, so the MapReduce jobs fetch the data stored in HDFS. And HBase is NoSQL system, also in the Apache Hadoop projects. Hive and Pig are mainly for querying the data, doing some statistics from the data. So this will be briefly introduced because of time limit. What we focus is MapReduce and Spark. And for AWS platform, well, it provides all the tools to you, almost all the tools to you, such as MapReduce, Spark, and HBase, Hive, Pig. When you create a cluster in AWS, you can just tick which tool you want to include it in your cluster. And then AWS will create a cluster for you to use. So it's very easy to use, but also very expensive. It depends on what kind of computers you are going to use. So some computers have very big memory, someone has very big storage, and someone have very fast CPUs. So again, depends on different applications. You choose which service you want to use in AWS, in the AWS platform. The last one is Mahout. So this is tentative. I haven't decided yet whether or not to include it in the lab. Mahout can be used for many machine learning tasks. But problem is that Mahout is not very efficient. So previously, it's mainly based on MapReduce. So when we learn MapReduce and Spark, you will know that actually MapReduce is not very efficient because it uses disk to do the data sharing. And so Mahout is not as a result, Mahat is also not very efficient. But now I think Mahat has already been trying to switch from MapReduce to Spark. So it means that the efficiency will be improved a lot. And by learning these tools, so we'll try to apply, we will use these tools to solve some real big data applications, such as finding similar items. We'll do, the last project is about this one. So you need to design some algorithms to find some similar items by using MapReduce and Spark on very huge data set. And for graph data processing, it's also based on, it could be used, it could be, so we can use MapReduce to solve graph data problems. And we can also use Spark to deal with graph data, and also other platforms such as Prego or Giraffe or a lot of other useful tools. And we will use MapReduce and Spark to do some tasks. Data stream mining. In Spark, it provides Spark streaming. And so we can see how Spark streaming can be used in data stream mining tasks. And finally is the recommender systems. So actually, Mahat and Spark machine learning library, MLlib, they both provide some collaborative filtering-based recommender algorithms. So it means that if you want to build a recommender for your application, actually, you can just invoke their method to call APIs rather than writing the recommendation algorithms by yourself. So it is very easy to build a recommender from scratch by using these tools. Okay, so that's the topics we will cover in this course. We'll use 11 to 12 lectures to learn all these topics. So actually, there's a lot of topic you can see. Again, I want to emphasize this again. So because this is a course, we only have 12 weeks. And also, I know that some of you may not be from computer science. You do not have too much computer science background. So that's why this course is not designed very difficult. And we try to cater as most students as possible. And someone may feel this course is very easy, but I still hope that most of you can find this course useful. Okay, if you feel that you want to know more about big data or you want to learn more, you can discuss with me, and I can give you some more resources for you to learn on your own. But for this course, so we still need to focus on these topics. It's kind of, like I said, kind of introduction or tutorial. And so you know these tools. So in the future, okay, so in the future, if you do something and you need to use these tools, at least you know where to start, right? So that's one of the major objectives of this course. Okay. Okay, so next I'll begin to introduce something about distributed computing and MapReduce and Spark programming, and also AWS. So before that, let's have another short break. Okay. Okay, so let's move to the last part of today's course. And thank you for staying with me. And I was seeing already some students have already left. Okay, so it's about the last part of this course about distributed computing and some introduction of MapReduce and Spark. About distributed processing, actually, it's non-trivial. It's a very not an easy task. So you can think about if you are going to do some distributed processing jobs. You need to do one thing on different computers to get the result. Okay, so you need to think a lot of things first, and how you can assign the task to different computers in an efficient way. How you can do this assignment, the jobs assignment, and what happens if the task fail? Okay, because if you assign one task to this computer, but something wrong may happen on this computer. It may shut down, or its disk may have some problems. So this task assigned on this computer may fail. What you need to do? How we can move this task to another computer? How we can detect the failure of this task? Right? And for the different computers, workers, how they can exchange the results, because the analytic task on one computer may rely on the data, the results from another computer. So you need to think about an efficient way to exchange the results across different computers, and how to synchronize the distributed tasks allocated to different workers. The data synchronization is also very important. So if you need to do a distributed task, you need to think a lot of details such as these questions. Okay, and the big story is also very challenging. So just now we are just talking about how to solve a problem, but think about how to store the big data is already a very challenging task. So assume that the data volume are massive. You are given a huge amount of data. How to store the data in a reliable way is very challenging. And you need to think about all kinds of failures, such as disk failure, hardware failure, network failures, right? All these failures need to be addressed. So if on one disk something wrong happened, it means that you may lose that part of data on that disk. So you can think about, you can use a replication to solve this problem. You just make a copy of the data on that disk at another location. Okay, but the problem is that another location may also fail. So for such kind of failures, how to deal with them is actually very, very challenging. And the probability of failures actually simply increase with the number of machines. The more machines you use, and it is more probable that you meet some failures. And you want to search something from the big data, it's just like find the needle in the haystack, that's shown in this figure. That's why Hadoop is developed for us. Okay, so these technical low-level details will be hidden by Hadoop. So Hadoop is a platform who deal with these details, deal with these low-level challenging tasks. What we focus is only to use the API provided by Hadoop to do the big data analytic jobs. So actually Hadoop, the idea of Hadoop comes from the paper from Google. So in Google, they published the most important 3 papers relevant to big data, called GFS, MapReduce, and Bigtable. So GFS is called Google File System. It's also a distributed file system. And MapReduce is a Google MapReduce computing paradigm. Bigtable is a tool for storing the data. The problem is that they can only be used within Google. They're not open to us. So we are not able to use these tools. And as a result, so by reading the papers published by Google, Apache projects began the following projects that's called Hadoop. And we have HDFS, so called Hadoop Distributed File System, corresponding to GFS. It's from the idea of GFS. And Hadoop MapReduce is also using the same computing paradigm as the Google MapReduce. And HBase, the idea comes from the Google Bigtable. Now they are open source, so we can use these open source tools for the big data problems. So that's how Hadoop was developed. It was named by Doug Cutting in 2006. At that time, he worked in Yahoo, and this is the name of his toy elephant called Hadoop. Hadoop offers us the following good things. For example, the redundant fault-tolerant data storage. So if you remember, when we talk about big data storage, you need to deal with a lot of kind of failures, disk, hardware, network, right? But now you don't need to care about that. Hadoop will do that. Hadoop deal with all kinds of failures for us. And for the parallel computation framework, and you also do not need to think about how to assign the different, first you have to split one huge task into smaller subtasks, okay? And then how you can assign these subtasks to different computers, and how to make them run in parallel, how to exchange the results, how to synchronize the data. All these details will be hidden by Hadoop from us. We don't need to know the low-level details. And also for the job coordination, it's also the duty of Hadoop. And what, as a programmers, we no longer need to worry about where the files are located. We know that the data are stored in HDFS, that's it. But where it is, doesn't matter, we don't care. And how to handle failures and data loss, we don't need to think about that again, because Hadoop already has very strong and robust mechanisms to deal with different kind of failures. And how to divide computation. And it's also done by Hadoop. And how to program for scaling. Scaling means that how to, when the data size becomes larger, you need to increase the computation power of your cluster, right? So what you want to do is to add more machines to increase the scalability of your cluster. But how to do that, actually, it's also a very, very challenging task in distributed computing. You need to rebalance all the data storage, and also need to rebalance all the tasks assigned to the different computers. But now, it is also the duty of Hadoop. So for your cluster, already installed Hadoop MapReduce. Now, you can just add more machines into the cluster, and Hadoop will do all the rebalance for you. Okay, and why we want to use Hadoop? Because it's cheaper compared to using very expensive servers. So we can just use very cheaper hardwares to create a huge cluster to get very powerful computation, and it can scale to petabytes or more very easily. It's also very fast. So it can do parallel data processing. And for a task, it can be run on different computers simultaneously. And also, it is suited for particular types of big data problems. Okay. And so it's kind of a very, very brief overview of Hadoop. So we have some text data. Okay, so the most simple type of data. We have some text, a document, a huge document. And this document, you can think it's a very huge file, right? Your computer is not able to hold such a huge file. So you need to seek help from Hadoop. So Hadoop will help you to divide this huge file to smaller files, smaller chunks. Divide this file to different smaller chunks, and put these chunks to different computers, to different storage locations. And because of they need to deal with the failures, so it will do some kind of replication of the different chunks. And so based on the storage provided by Hadoop, and you can also do some map and reduce jobs. So we call it map and reduce. Well, it's hard to explain what is map and what is reduce. So I will use an example to explain the two steps later. And by using the map and reduce jobs, so we can finally obtain some results. And the results will also be stored in HDFS provided by Hadoop. And we can access HDFS to get the results to your local machine for further analytics. Many companies they are using Hadoop for their daily tasks, such as eBay, Facebook, and Visa, Samsung, Yahoo, Netflix. So these companies use different kind of tools provided by Hadoop to deal with different applications. Hadoop is just a set of Apache frameworks and more. The lowest level, the lowest layer, is just HDFS. It's about how to do the data storage. So it's called a Hadoop distributed file system. It's just a file system. It organizes the files as a tree structure. And just like your file system in Linux, okay, and it runs on commodity hardware, usually Linux operating systems. And it is horizontally scalable. It means that you can just add more machines, add more cheap machines into your cluster to get more powerful computation. And the next layer is upon Hadoop storage is called MapReduce API. So the data is stored in HDFS. And next, if we want to do some job, we utilize map and reduce the two functions, two jobs to do the data processing. And the map jobs can be done in parallel on different computers. And then after all the map jobs finished, the data will be exchanged and sent to the reduced jobs. And the reduced jobs will also be run on different machines in parallel to get the final result. Okay, so that's about the data processing using MapReduce API. And upon MapReduce, you can do a lot of different things, such as data access, HBase, how peak, and how. So you can access the data. Well, it's not very accurate to say that HBase is also based on MapReduce. But anyway, you can think about that. Okay, MapReduce provides a way to deal with data processing using map and reduce. And these tools provide different APIs, but actually these APIs will be transferred to map and reduce jobs into to the lower layer. And we also have some other tools, and these are also Hadoop subprojects. And there's another figure that can be used to explain the framework of MapReduce. So Hadoop storage, some more details. Okay, so as a site, the storage need to deal with different kinds of failures. So in HDFS, for each data, each piece of data, it's called a chunk. It will create 3 copies. It uses data redundancy to guarantee the problem, to guarantee that data will not be lost. And for large files, so it will divide the large file into different blocks of 64 megabytes or 128 megabytes per block. And it can scale to thousands of nodes in one cluster. So upon the HDFS storage, and MapReduce API will be used to fetch the data from HDFS and to do the parallel data processing. And upon MapReduce, map and reduce jobs, so we have more tools, Peak, Hive. So these tools provide users different APIs. So the user do not use map and reduce programming to do the jobs, but use, as for example, in Hive, it provides you SQL-like comments for you to use. You can use select from where. Hi. It's not a server actually. It's just kind of a computation node. Yeah. So if you talk about server, normally it means that you use very expensive hardware to achieve very good computation ability, right? But in Hadoop, it's not necessary to use expensive servers. Yeah. Okay. This framework is kind of called Hadoop version 1. And in Hadoop version 1, so HDFS, then MapReduce is in charge of cluster resource management and data processing. And then upon MapReduce, we have Peak or Hive. So for Hive, we have, for example, we have SQL-like comments. And so we just need to write SQL-like comments, select something from a table where according to some predicates. And then this comment will be compiled and translated to map reduce jobs. And to the lower layers, map reduce jobs will be run in parallel. and fetch data from HDFS to get the results. So that's Hadoop version 1. But the problem is that this is not very general and also not very efficient. And after a few years, so Hadoop decides to move from version 1 to version 2, a much more flexible framework and provide a much more powerful platform and also more efficient. It can use to deal with different applications. So the framework is like still HDFS, but with some improvement called HDFS 2. And upon HDFS, it's not directly MapReduce, it's Yarn. This is cluster resource management. Well, in your first lab or second lab, you will run some MapReduce job. I have to say, so locally, because you are using MapReduce on a single machine, and you create this, you configure Hadoop as not a real distributed mode. It's actually it's a pseudo distributed mode. So on one machine locally, using Yarn actually is slower than without using Yarn. But in the real platform, in a real cluster, using Yarn is much more efficient because it can balance the resources used in different computers. Okay, so that's why you can observe something different on a local machine. I just want to say this in advance before you do the job, do the lab. Okay, upon Yarn, so we can do different things such as on HBase, and for stream processing, we can have Storm, or for graph data, we have Giraffe, and for Hive, Pig, and MapReduce, it's based on another exception engine. And so in this framework, you can see there are more layers, but for each layer, it has been improved to get better efficiency, and also has been extended to deal with more jobs. So previously, MapReduce can only be used for batch jobs. So batch means that, if you still remember, means that the data is given to you. Okay, so you just do something based on the data, and you can scan the data as many times as you can, as you want. But for streaming data, normally it's not possible to store all the streaming data because streaming data is so huge, and what you can do is to use very limited resources, such as some memory or some disk, to store some information for the stream data that passed by your system. And this is not a batch processing. It's called streaming processing. It's a different way of dealing with streaming data, not the offline data. And Hadoop version 1 is not able to deal with streaming data, and in version 2, we have more tools built upon HDFS and Yarn. Okay. Now in our lab, so actually now Hadoop has version 3. It's called Hadoop 3.0 and 1 or 2, I can't remember exactly. It's just released something recently. But the most stable released version is still Hadoop 2.72. So that's a version we used in our lab. Okay. Actually, it doesn't matter much for our projects because we will not touch very advanced topics. So you do not have to worry which version you installed in your computer. Okay, so previously Hadoop is only for batch applications, but now you can do batch application and streaming online applications and also interactive applications. So you can do queries to the system and get the instant feedback from the system by using some tools in Hadoop. Okay, some more tools displayed in this figure. So in the core of this figure is called HDFS, MapReduce, and Yarn. So built upon these core parts, so we can have different tools for different applications, such as data access, use Pig and Hive. You can think about this like a kind of a SQL Hive. And HBase is for storage. It's kind of similar to HBase, but not HBase. Similar to database, but not database. A tool for data storage, and some other tools for different applications. Okay, so that's about the Hadoop ecosystem. I think maybe I need to update the figure a little bit because this is about the figure about two years ago. They have much more tools in the Hadoop ecosystem. So anyway, for Hadoop, it is a huge project. It provides you a lot of tools for you to use. But as a side, you need to analyze your problem first. You need to know what kind of data you want to deal with and what kind of problems you are trying to solve. And based on the problems and the data, you decide which tool to use to best match your requirements. For the Hadoop, we have different distributions, just like Linux. You have different distributions. Open source is just Apache Hadoop. That's what we will use. But there are also commercial distributions, such like provided by Hortonworks. Hortonworks also provides a virtual machine. Hortonworks. And this virtual machine image also already integrates MapReduce, Spark, Hive, HBase, a lot of open source Hadoop tools. And MapR also provides some online courses. So if you are interested, you can also go to the website of MapR to register some online courses. It's free. It's not. It's for free. And AWS MapReduce. So that's what we will use. In the last project, it is not for free, but anyway, for each student account, AWS provide 100 credits for you to use. So it would be enough for you to practice and to finish the last project. And also Microsoft provides Azure to also for MapReduce. I think Apache is most widely used because it is open source and easy to get. For setting up Hadoop development, well, you can use different ways. Locally, it can be installed on Linux, Windows, or Mac, so it doesn't matter. The data storage could be a file system or just file system or HDFS. In cloud, there are different services providers. And you can also install the Hadoop on virtual machines. That's what we do in the lab, and also like the image I provided to you. Using the virtual machine image, it's good thing is that you will not ruin your own computer by some mistakes. But the bad thing is that you will not be able to get a good performance. But anyway, if you do not have enough background, I still recommend that you use the image provided to you, which has already pre-installed Hadoop. That is easy for you to focus on MapReduce programming. And later, after you get familiar with MapReduce, you can think about how to install Hadoop, configure Hadoop on a raw operating system. Okay. Comparing RDBMS and Hadoop, I think this table gave a very good summarization for the comparison from about 11 different perspectives. So for data variety, RDBMS is only used for relational data, for structured data. And you use tables to represent the data. You use SQL to, it's about querying. You use SQL to query, to retrieve the data. And in Hadoop, it can be used for structured, semi-structured, and unstructured data. So all types of data can be used in Hadoop. But the problem is that it's hard to design a querying language, a standard querying language for Hadoop applications. Well, HQL is only one language that can be used. So it is based on Hive. So it means that you need to use Hive for your application, and then you can use HQL to do the querying. But if you do not use Hive, and you use some other tools, such as you just use MapReduce or use HBase to do your job, then HQL cannot be applied. So there's no standard query language in Hadoop. And the data size, that definitely Hadoop is designed for big data. It can deal with much larger data set, terabytes, even petabytes. And for schema, well, in RDBMS, you must define the schema first. Okay, it's required on write. It's a static schema. But in Hadoop, it's dynamic schema. It depends on your data. And during creating the storage, well, we can dynamically define the schema in Hadoop, in HBase. So we will see some examples when we learn HBase. So that's one major difference. And for speed, in RDBMS, the read is very fast. In Hadoop, both read and write are very fast. And Hadoop is open source, so it's free, but RDBMS normally is commercialized or licensed. And use case for Hadoop, it can be used in many types of big data applications, big data analytic problems. And for RDBMS, it's mainly used for online transaction processing. And for the data objects, well, you know, in relational database, it's based on tables, on relational tables, right? And in Hadoop, it's based on key value pairs. When we learn MapReduce, you will see how we model the data as key value pairs and how we do the data processing using key value pairs. The throughput of RDBMS is very low, and Hadoop is very high. It's because of the design of ATFS. And for scalability, it's vertical. Vertical means that we can only use much more expensive hardwares to improve the computation power. Okay. Throughput means that data you can generate it within a 1 unit time. So for example, how much data you can read in 1 second. Yeah. So because of the HDFS design, it assumes that you do sequential read or sequential write. So at 1 unit of time, it can read or write a lot of data. But RDBMS does not assume this. It can use random access. It means that in the disk level, you need to go to this block and then link to another block. It's not a sequential scan, so it's much not slower. So it's the throughput. So for in 1 unit of time, it cannot be able to generate too much data. So that's the difference. Okay. And for scalability, the vertical means that you can only try to using more expensive hardwares to improve your computation power. But for Hadoop, it's horizontal scalability. You can just add more machines, cheap machines, into your cluster to improve the computation power. That is because now it is a distributed processing, right? So now the data can be stored onto more machines, and more jobs can be run in parallel. So that's why by adding more machines, you can get a better performance. So that's on scalability. And hardware profile, or like a site, because also when talking about scalability, in RDBMS, you need to buy a very good server to install this database system. It's a high-end servers. But in Hadoop, you don't need to buy very expensive servers. You just need to use commodity hardware to create your cluster. And integrity, well, can guarantee ACID. Do you still remember what is ACID? Automate. C, consistency. I, isolation. And D, yeah. Who taught you your database? How can you forget this important concept? I'll tell him. But for Hadoop, it is low. It cannot guarantee ACID. Okay, so that's the difference. Yeah. Okay, so the changing data management landscape is as shown in this figure. And RDBMS is still very useful in many applications, especially the data size is not that large and the data type is not that complex. Okay. I have to say, in Australia, I think there's not too much market for Hadoop. But in US, many companies are using Hadoop. So, okay, I have to say my course is not that useful for the students in Australia. But Hadoop now has become not just Hadoop, Spark or some other big data processing platforms begin to dominate the marketing of data management, and also some other services not inside the Hadoop management, Hadoop project. They suit different applications, such as for graph, for streaming, or for some other types of data. We have different tools. Okay, that's about a brief introduction of Hadoop. Now let's look at some concept about MapReduce and Spark. And although we will learn them later, but now I would like to give you some a taste of these platforms. Okay, so okay, here is still a general problem. So it's about the philosophy to scale for big data processing. So giving you a task, so how you can deal with this task in a distributed environment. So we have different computers, how we can do that. So we use divide and conquer, right? So we divide this work, this job into subtasks, and each subtask will be assigned to a worker. So here we have work and divide to 3 sub jobs, and each one is assigned to one worker, to one computation node, to one computer, and it gets some results, and then we merge the result to the final result. Okay, so that is a philosophy. And this is a general philosophy. So as a result, both MapReduce and Spark, they adopt this philosophy to do the big data processing. We all need to divide this task into subtasks, and then think about this subtask, how this subtask will be processed on one computer, and then it produce some partial results. And we need to think about how we can combine these partial results to the final result. Okay. For MapReduce, well, it adopt this philosophy. So for a big data problem, so MapReduce can map to the following steps. Okay. So giving you this problem, you have a huge amount of data. So what you need to do, you need to iterate over this large amount of data over each record, and then extract something from each record. Okay, it's just like select something from select some column from one record, and then to do some jobs, and then you get some intermediate results now, right? So you need to exchange the results on different computers, and to get the partial results, and finally you need to aggregate the results to generate the final output. So map corresponds to the first 3 steps, and reduce corresponds to these 2 steps. So what does map do? Map reads the input. The input is already split into small chunks. Okay, and for each piece of data, so map do some job to generate some intermediate results, and next, these intermediate results will be shuffled and exchanged across different machines, and then sent to the reduced part. So the reduced part will aggregate these intermediate results to generate a final output. But I will use an example to explain these steps. So I know it's not very easy to understand at this stage. Well, the key idea is that in MapReduce, it should provide a functional abstraction for the map and reduce the 2 operations. To be more specific, in MapReduce, we have 2 functions. So as programmers, we do not care about the low-level details, but we need to define map and reduce. So the 2 functions. For map will take a pair of key value, will take 1 key value pairs as an input, and it generates a list of key value pairs. So we can think about map just deal with 1 record, and from this 1 record, it generates some intermediate results. The intermediate results are also represented by some key value pairs, but it's a list of key value pairs. It depends on your application. And in the reduce step, it also takes key value pairs as input, but this is the key and the aggregated values associated with this key from the result of map. And in the map reduce function, by taking this input, so actually you aggregate all the values relevant to the same key together for one reduce function. So the reduce function will deal with this to generate the partial results based on this input. And finally, all the values with the same key will be sent to the same reducer. So you can see from this function, the same key, all the values associated with the same key will be sent to the same reduce function for processing. And this is a partial output from this reducer. And finally, the final output can be obtained from all the output, from the output of all the reducers. So that's what programmers need to define, map and reduce. And then the execution framework, Hadoop, will handle all the other things, the low-level details. Well, I know it's still not very clear to you. Okay, so I will use word count example to explain the basic ideas. But now I still want to show the step of MapReduce in a high-level idea. So the input is the map takes one record represented by a key and a value. So normally the value is the record itself. Key is just an identifier for this record. It takes one record from the data. And next, it will generate a list of key value pairs from this input. And these are the intermediate values. Okay. And from this intermediate result, so we'll do, not we, the Hadoop will do some shuffle and sort. And this shuffle and sort means that from different mappers, we have different key and value pairs, right? And they are generated on different machines. So now in this step, the values relevant to the same key will be grouped together. So for all the values relevant to K2 from different machines, from different mappers, will be grouped together and then sent to a reducer. So list V2 is all the values generated in this map phase. And after shuffle and sort phase, the list is generated. And in the reducer, so we get a key K2 and a list of values relevant to this key obtained from the map output. And then we combine then we do some further processing to generate the final result as a list of key value pairs. Okay. The format of the MapReduce is like this. So this is the input. Well, we will format the input as a list of key value pairs. And using a collection of documents as an example, so we have a lot of documents. And then each document is a record. And we can use a document ID to identify this document as a key. And then map is to process this document to some key value pairs. And combine will combine all the values relevant to the same key together and then send to a reducer for processing to generate the final output. So that's a high level of MapReduce. But how it can be used to a job, to a big data job. So that's what we, that's an example, like a hello world example in MapReduce. When you begin learning a new programming language, you always start from hello world, right? So this is just like a hello world in the other language learning. It's called the word count example. So what does word count do? So you are given a collection of documents, given a huge collection of documents. And what you want to do is to count the frequency of each word appearing in this document, to count the number of the appearance of each word. So the input is a collection of documents, okay? We format it as the document ID and document. So this is one document key value. And we have a list of such key value pairs. This is the input of this job. And the output is term and the term frequency. Is each word appearing in this document and the number of its appearance in the whole collection. So that's a problem definition. Okay, I'm not sure if you understand this problem. It should be easy, right? Now, okay, so let's forget about MapReduce. Just think about if you are using Java, what you will do, or Python, what you will do, how you can program for this problem. Okay, so you read one document one by one. Okay, for one document, you split the document into words, right? And for one word, you should use a hash map to store the final results, right? So in the hash map, for given one word, you first check if in the hash map if the word already exists. If it does not exist, so okay, you add a word and its frequency 1 into this hash map. And if it already exists, you just increase the value of this word by 1. right? So that's how you do in Java or in any kind of computer language. So that's it. Okay, so now let's move a little bit further. So we are using Java. Okay, still forget about MapReduce. We are doing it in a distributed environment. So assume that data is on different machines. So we do this job by manually dividing in these documents into different machines. Okay, we have some documents on this machine, some documents on this machine, some documents on another machine. Okay, and now how we can get the final results, right? So on each machine, you still need to use a hash map to get some partial results for the documents stored on this computer, right? And okay, for this machine, on this machine, 3 machines, we have 3 hash maps. So one hash map gets some partial results for the documents on each machine, right? So this is a partial result. Okay, finally, how we can get the final result? We need to merge, we need to combine 3 hash maps, right? So we scan, we get one hash map and scan the next hash map. So for each entry in that hash map, we check the key, which is a keyword, to see if this keyword is contained in the first hash map. So if so, we just plus the 2 values, right? And if it does not exist, we just put this entry to that hash map. So by doing this on all the hash maps, we get the final output, right? So that's a distributed processing for this word count problem. Okay, now let's come back to MapReduce. Okay, how to say? So first, let me ask you if you can understand what I have talked about for the distributed processing of this word count using some language, using the hash map, right? So it's just adopt the philosophy of the distributed processing. Remember, show this figure. We divide this this work into subtasks. We divide this huge collection to different parts, and each collection is sent to one worker, one computer for processing. And for each worker, it will generate a partial result, a partial hash map to compute the local frequency of the words in this worker, right? And we get some partial results, some some hash maps, and then we combine them to get the final results. Okay, so that's the idea of the distributed processing. In MapReduce, actually, the ideas is the same, but the processing is a little bit different. We summarize the processing steps as map and reduce. So let's look at how the MapReduce will solve this problem. So again, the input is document ID and document itself. Okay, it's called query ID or query text. It doesn't matter. So that's just the identifier of this document and document itself. Okay, so this is the first one. And so in Java, we use hash map to do local computation for this, right? And in MapReduce, we can simply just do this. For each keyword appearing in this document, we generate a key value pair, which the key is the term itself, and the value is 1, means that the term appeared once in this document. So this is the map phase for the word count MapReduce job. Okay. After this map phase, you can see this document. Remember what is a document? It's a key and a value, right? It's converted to a list of key value pairs. So this is the first step. Key, document ID, document map to a list of key value pairs, a list of term and ones. So that's a map phase. Now we finished this map phase. Next, it's about shuffle and sort. So it's about MapReduce. So anyway, we don't know. We just know that MapReduce will group all the values for the same key. So for example, for it will aggregate all the ones for this so that's a reducer job in the reducer part. And after the shuffle and sort phase, MapReduce will aggregate values on the key. So this is the output from the mapper, right? And the reducer will sorry, I made some mistakes here. So the reducer will receive some key value pairs like actually it should be like store should be 4 and it's better to get it from here. I'm sorry. And this is the output of the mapper. And next, the Hadoop framework will group the values for the same key. So for example, it will group all the ones to the key. And so actually in this result, there are 6. And in the reducer, so this mapper will send the 6 to one reducer. But actually, remember that we have many documents. So some documents will be processed by another computer, right? Assume that we have Q2. And Q2 can also being processed by the mapper and generate some results, also like this. And by the shuffling, grouping, and shuffle and sort, and it will also get some results, partial results. And the reducer, what the reducer will receive is actually a key and a list of values. And then the reducer will aggregate the key and values from the different parts to for further processing. This example is not good because it does not consider more documents. Okay, so let's. I'll try to explain it again because I think I didn't make it clear. So assume that we have only one document and only one mapper, and what the reducer will receive is a list of key and values. So the key is the and the list of ones relevant to the. And in the reducer will sum all the values for the same key. So in one reducer, it will receive the and 6 ones. So in the format of this, it's a one, this keyword, and a list of ones. We have, in this list, we have 6 ones. And so in the reducer now, it is easy to get the frequency of this term. It's just to summarize all the values for the 6. So using store as an example, okay, so for store for this keyword, one reducer will receive all the values attached to store. So it will receive 1 key, store, and 4 ones, a list of ones containing 4 ones for this store. So that's in the reducer. Now, this is the input for the reducer. And what the reducer will do is just to sum all the values for this key. So for taking store as an example, it will sum all the ones, sum 4 ones. So we will receive we'll generate a final output like this. Okay. So let's go back to this high-level data format. In this word count example, what we will generate. So this is document ID document and the local key, local term as a key and the value 1 as a value. It's for the map output. And then combine, this step will combine all the ones for the same key. So using store as an example, so it will combine 4 ones in this list. So what does the reducer receive? It will receive restore as a key and 4 ones in the list. So and in the reducer, because this is a very easy task, the reducer just do a sum for these ones to get the frequency of this term in this in the document. Okay. So I'll try to use another example to describe this process again. I think this is more clear because in this example, there's only 1 document, but now we have 3. Okay, assume that we have 3 documents. The first one is Deer, Bear, River, and next is Car, River, and next is Deer, Car, Bear. So think about we have 3 documents, and each document is processed by 1 mapper. So this one processed by 1 mapper. We have this result as keyword and 1. Right? It's a list of key value pairs generated from the first mapper. And this is second document processed by another mapper, and also generated a list of key value pairs. And the last one processed by third mapper and a list of key value pairs. So this is the shuffling and sort phase or combining phase. So it combines the values for the same key. So in this example, it will combine the ones for bear, combine the ones for car, combine the one for deer, combine the ones for river. So after combining, this will be sent to a reducer. So in this reducer, it receives one key bear and a list of ones. So in this example, there are 2 ones in this list. And the reduce functions just do a sum of these ones, so get a 2. And then it gets, for car, it gets the result is 3, for deer 2, river 2. So you can see the whole process. This example just shows 3 documents. But if there are huge number of documents, so each document will be processed one by one mapper, generates one list of key-value pairs. And the keys are the term in this document, and value are just one. And after this combining step, so all the ones for the same key, for the same term, will be grouped. And this key and the list of ones will be sent to the reducer. And in the reducer, it just do a sum for the values associated with this key, which is appearance, the number of appearance or the frequency of this term in the whole collection, right? So now you can, I think it is more easy to understand the map and reduce phase now. So using the second example, now let's try to see the data format in the map and reduce process. So map, we have a list of documents, and each document will be processed by one key-value pair, right? And then generate a list of key-value pairs, the terms, and one. And then this combines these key-value pairs, combine the ones for each term. And in the reducer, it will receive a key and a list of ones. And the reduce function will do a sum for these ones to get a frequency for the result of this key. So generate a list of final result. So each key-value pair is one key, one term with a total frequency in this document. Okay, so that is MapReduce process. And from the next lecture, I will begin to introduce more details about the MapReduce mechanism and how we can use MapReduce to deal with different applications. Word count is a very easy example. Okay, and next is about a brief introduction to Spark. For Spark, this was developed in 2009 by UC Berkeley. Now it's commercialized already by a company called Databricks. So in our course, we will briefly touch Spark and use Spark to do some jobs. Well, comparing Spark and MapReduce, so why we need Spark even if we already have MapReduce? The main reason is that in Hadoop, it uses HDFS to store the data and also to share the data across different computers, which is not efficient since disk access is not very fast. It is slow, right? So Spark uses memory to do the data storage and to do the data exchange. So as a result, it can achieve much better efficiency. And also, it's not just restricted to map and reduce function. It has more general computation graphs. It has more operators and also more rich APIs in Scala, Java, and Python. Well, Spark is a not modified version of Hadoop. It's totally different. Okay, so it's not just extension of Hadoop, and also it does not depend on Hadoop, and just use HDFS for storage purpose only. According to some studies, about 100 times faster if Spark use memory, and about 2 to 10 times faster, even all the data is on disk, just because Spark has a better computation paradigm, not just restricted to MapReduce. And we have 4 components in Spark. We will introduce in later slides, in later lectures. So I'll skip this. Well, I think this is a very good example to show how Spark is like. So we have different functions. Map, reduce are supported by Spark as well, but we also have filter or some other functions we will learn later. So in this example, you can see map, we send some data and a function to map. Okay, we send a coin, some beef and a chicken, and cook is a function. Okay, so map will apply this function to this input, and we get popcorns and burger and eggs. Okay, so that's a map step. And filter. Okay, so this also apply a function to this data. It's vegetarian, so beef is not, burger is not. So we just filter it out. We get popcorn and eggs. And reduce. Okay, eat is a function. Okay, reduce, we also apply the eat function to this data. So we get, okay. So it just explains ideas of Spark. It's different from map and reduce. It has more functions to deal with data. But you see, it will, actually Spark is based on functional programming. So you pass a function to this map function as an input. And this map function apply this function to the data you send to this function and get some result. And this result can be further processed by another operation. So that's about Spark. It's a little bit complicated to explain the word count in Spark right now, but you can, I can show you that there's a transformation step and there's a final action step. And the process actually is almost the same. Still, so flat map is to map the document to the words, and then word to word one, transform the word to a pair, and then do aggregation, reduce by key. So this is just a code for word count in Spark. But when you learn MapReduce, you will see how complicated it is to use Java to write MapReduce tasks. Okay, so Spark is way much easier to use. And because of time limit, so I'll skip this. I'll just tell you that you can apply AWS account right now, but you can also apply for the AWS Educate, but do not claim the credit right now. You need to do this during the lab, because the tutor will help you. Otherwise, you may meet some problems. You need to give them a phone call for verification, and you also need to provide your bank account. You need to provide a credit card. But don't be worried about that, because they will not charge you anything, just for the verification. And then you will receive an email. So normally you will get 100 per year in AWS. You can use these credits to do the labs and for the projects. Okay. I'm not sure if you, if you get some problems, then you can discuss with the tutor or discuss with me. Okay, hopefully everyone can get this $100. So sometimes you may get some problems. Hopefully this year we will not meet this problem. Okay.